Hi guys, in this video I will walk you through the codes that I used for lecture 2. If you haven't watched lecture 2 yet, please follow lecture 2 so you can follow this video. The link for lecture 2 will be under this video. So before we start, I will first try to increase the font so you can follow with me. So let me just go to Tools, Appearance, and in Appearance I'll just increase the font. Let's say 14. Let's see how big that would be. I don't even mind to make it 16, just make it even bigger. Okay, so I think that will do. So the first thing, the first line here, this command I use to clear the environment, so to delete all the saved objects. So I'm starting a new session, fresh session. I'm deleting all the objects if I don't need them. This line will clear the console here. So if you have any line here like this, for example, so anything written in the console will be deleted if I execute this command, this line. This is actually equivalent to Control plus L. The package I used in this lecture was POE data, which is stands for Principles of Econometrics, the data sets from this textbook. And we learned before how to install a package, and we learned also that you need to install a package once. That's why I'm not going to execute this command, because I already installed this package. But every session you need to activate your the package, so using the command library. So I'm going to do that. So now I activated the library, the Principle of Econometrics, or POE data library. And also we will be using Stargazer to produce tables. So I'm going to activate Stargazer. So if you haven't installed the Stargazer package before, then that means you need to install it first. And we said we need to install a package only once, and then every session, every new session, then you'll need to activate the library. So I'm going to activate the library. In the first example, we had a very simple regression model. We use data on food expenditure and income. So to call the data, so I use the command data, and between the brackets the data set called food. So when you execute that command, you will notice here that you have a new object here called food. If you press here, you'll be able to see the data. So you have data on food expenditure and income, and that was about 40 observations here. So going back to the going back to my code here, if you want to see the first few lines in your data, so you can use command or function head, between the bracket food, the name of your data set or name of your object that you want to examine. So, and that's what you can see in my slides. So food expenditure, income, this is the head of the object or the data set or this data frame. You can have you can look at the first few entries or first few observations in your data set. So as we said in the lecture, you need to the first thing to do, you need to produce the summary statistics of your data, and to do that I am using here Stargazer function. And as you can see, Stargazer, you open bracket, and then the first thing here I put the food, which is my object, which I want to produce the table for, with summary statistics for. Type text, you can use different other formats, but I'm using here text just to produce it in the console, and it will show you how it looks like. But then if you need help with what other types you could use with Stargazer, we learned before that you could go to the help file by just typing question mark and the name of your function, and that should and when you execute that, that should take you to the help file. So here you can know more about Stargazer and other options you can use with Stargazer. But for now, I'll stick to what I have done in the lecture. So so far, yes, we have food. Food. This is the object I want to produce the table for. The type is text, and the title, I just give it a title. Descriptive statistics. I choose to round it to 2 numbers. I don't want to have um, uh, uh, very large table, big table. So to control the size of the table and to make it easy to read, and I choose to omit some statistics here from the descriptive statistics, and then if you execute that line, then here we go. So these are the descriptive statistics of our data set. As you can see, we have 40 observations, n equal 40. This is the mean of the food expenditure. This is the mean here for the income, standard deviation, the minimum, maximum, etc. Okay, and this, you can see this in the slides in lecture 2. To plot the data, I use the basic command in R plot. So what I wanted to plot here is 2 variables. So I asked it plot function to take the variable income, and we learned before, if you want to call an object inside this data frame, if you want to call a variable inside this data frame, then you could easily do that by type the name of your object or your data frame, and then with the $sign, that will give you what variables, what other variables within that, inside that data frame. And as you can see, we have 2 variables here, or 2 columns here, the food expenditure and an income. So what I'm doing here is I'm trying to plot both against each other. So that's why I'm calling food income variable against food expenditure, which exists within the this will be helpful because sometimes you'll be dealing with different data frames, different objects in your environment, so R knows exactly where to look for what variables that you ask to plot. And in this, okay, and in that sense here, I'm just giving a label for income. Income was measured in $100, and so this is X label. So this is the horizontal axis, this is the vertical axis label, and if you execute that, then let's see what we get. So I'm going to execute this. Now we have a scatter plot, and again, this is the scatter plot you could see in my slides. So the point here was to use this very simple and very small data set to run a very basic linear regression model. And to do this, I just give it a name. So I call it Mood 1, but you could call it anything. And the function here is LM, so that's linear regression or linear model. And the way you enter the variables, we know that food expenditure is the dependent variable in our model. So that's why we start with our dependent variable, and then followed by this sign here, and then you put the independent variable, which is income, and after the comma you tell the function which data to use to apply this regression or to execute this command. So the data here equal food, as you see here, this is the name of my object here, or my data frame is called food. So once you do that, then if you run this line, you'll see here that there's a new object called Mood 1 or Model 1. That's how I called it. So you can give it whatever name you want. And here is a we want to produce a table. As we said, we use Stargazer to produce nicely looking regression tables. And again, the same in a similar way, the way we use Stargazer here. So what you need to do is just you pass the object, what object you want to produce the table for, and in that case is Model 1 or Mood 1. That's what I want to plot. And again, I choose the type text, and I change the font size, make it a bit smaller to fit in my slide, and I give it a description to title, sorry, to the table, for the table, again the digits, and I choose single row because I wanted the you will see, I wanted the standard errors to be on the same line with the with the estimated coefficient. So let's just plot this one. So you could see here, these are the these actually not the standard errors. This is probably the t, yeah, so the t value. So anyway, so the t statistic. So anyway, so rather than having the t statistic or the standard errors below the coefficient, I just want it to be on the same line. So that's why I choose single row equal true. So that produces the regression table that you could see in my slide, and then I wanted to produce the same plot, this scatter plot. I want to produce the same, but I wanted to add a line, a regression line. So first I stored the coefficients from this regression here from mode 1 into I called it B1 and B2, which is the estimated coefficient for beta 1 and beta 2, but you still can call it whatever. But the command to do that, or the function to do that, is the coefficient, and then the coefficient you call this from module 1 here, and then you choose the first coefficient here, and this is like within that I want the first one, which is beta 1 or B1, and the same thing here for the second one, which is the slope. So this is the intercept, and this is the slope coefficient, and then I'm using exactly the same command here, plot it again. So I'm just plotting the in these few lines, I'm just plotting the scatter plot again. It's not going to do anything new, it's exactly the same, but then I just want to add the line, AB line, to the scatter plot, and I'm just passing the main parameters that I need for that, or the main coefficients here, which is the intercept B1 and which I already defined here from based on the regression model, and B2, which again I call it from, or I store it from the estimated coefficient. So when you do that, when you run this line, I didn't run that, sorry. So I need to first to store it. So it tells me that you can't find object B1 and B2. So obviously we need to, I didn't run this first, so you have B1 and B2 is stored here, and then once this is ready, then we could just add, now you see the line is added to the regression, to the scatter plot. Then we moved in the lecture to use this model to predict, so for given income level, how much food expenditure would be. We already have the model, so this is the same model, so I didn't change anything, so we actually don't need to run that one. But I passed some values for income, which is here 20, 25, 27, 29, and 30. And remember that the income here is measured by hundreds of dollars. So that means if somebody or a family or a household receive $2,000 or 2,500, 2,700, etc., I want to see how much they would expect they would spend on food expenditure based on the estimation from my regression model. So what I'm going to do here, okay, so I'm going to run these two. So I don't need to run this again. So I already actually have this already stored. So I'm going to save. I'm just going to delete it because I don't need it. I already have this regression line here, regression estimation here, or this object. And then I'm just creating a new data frame called income, where I'm actually storing which level of income that I need to. So this is a kind of vector here of a number of values here, which again, the reason I'm using 20, 25 is the way just data is measured by hundreds of dollars. And I'm creating a new object called y hat to use the function predict, and within that function I'm passing the model based on which I'm making this prediction, and these are the set of the independent variable or the given level of income at which I want to project the food expenditure. So once I do that, then we have the new object, and then I'm changing. So I'm using this to change the names within that new object. So the new object, which is y hat now, include like I just when I create the table, rather than I wanted to have 20, 25, 27, 20, 29, etc. I want actually to be more presentable, so I can show that this is actually, it's not 20, it's $2,000, etc. So that's exactly what I did here. So I'm going to change that to new names, income equal 2,000, 2,500, 2,700, etc. And then I'm going to print that on the screen for you to see it. And in the same time, we saw that function round before. Again, I want to round to the second number. So let's see that. And now here we go. So the first line is, again, this is what the new names that I give to this object. So it's 2,000 at 2,000. So if somebody received 2,000, they are expected $2,000. They expected, and I think that was the weekly income. They would be expected to spend 287.61 per week on food. So that was the first example. And before we move to the last one, to the second one, so the second example here, I did some I show you this code in the lecture where n is the number of rows, which is the number of observation in food, in the data frame food, so that we know it's 40, but I'm just passing this into a new object called n, and I want to withdraw different samples to take sub-samples from this sample, from the 40. So I want to have 50 sub-samples, so I call it C, and then the sub-sample size should be 38 observations. So once I do that, then I define the main parameters here, and then within this I'm creating a loop here. I'm writing a loop to actually every time to take a subsample and return it, and then take another subsample, and every time in this line here I'm asking to re-estimate the model, not using the full sample, using the subsample, and at the end I'll sum these together, as you can see here, and divide it by the number of subsample we have to get an average how much the parameters, the estimated parameter would be. And in that case, so let me run this piece of code, these few lines, and that's what we saw in the lecture. And as you can see, it was 9.89. Okay, so that was the first example we did in lecture 2. So remember, this video just walking you through the codes that I used to produce these slides in lecture 2. The second data set we used in lecture 2 was from the same package, but it's about house prices. So I used I called data BR, so I called the data called BR, so the data set. So I'm going to execute this. Once you execute this, you have it loaded here in your environment, and when you click on it to check, so these are the price, square feet, number of bedrooms, bath, etc., whether it has a pool or not, swimming pool or not. So this is the sort of data set we use. This is the data set we used in lecture 2, and as usual, I just produce the descriptive statistics using a table of the summer statistics using Stargazer. So now we are familiar with Stargazer. So here I produce the histogram of the price from the, as you can see, this is the data frame BR, and then within that data frame I'm actually picking the price. So I will execute this line. This will give us the histogram for the price, and I compare that with the histogram of the log of the price, just to show you that how using the log move us or make the distribution of the dependent variable closer to the normal distribution. So if you compare this one to this one to the next one, this is more like a normal distribution. So, and then we run the model where we have log len, so we have log of the price regressed on the square feet. So this is what we have here. I call it mod 4, and again the function is linear model, is LM, and then rather than using the price, I use the log price as dependent variable, and remember this sign, and then you add this one here, and then followed by the independent variables. So we have only one independent variable here, which is the square feet, and then comma, and then you add which data set to look or to pick these variables from. It's data equal BR. As we said, we loaded this already in our environment. So I'm going to run this line, and then once you execute this line, you could actually, so the results are stored in this object mode 4, but to make it more presentable and more nicely looking table, so I'm going to use Stargazer again. Now we are familiar with Stargazer, so I'm not going to repeat that. So here we go. So this is the table you will see in the next piece of a few lines of codes. I'm actually trying to plot the scatter plot of between square feet and the price, and to do this, and adding as well a regression line, and that's what we see in the slides. Okay, so let's move to the next example. In this example, we move to look at linear log models, and we use the food expenditure food data set to show this on the slides. And this is why I ran this regression. So execute this command. This again is very straightforward, but now rather than using we use food expenditure, regress food expenditure on income in the previous example, in the first example we gave in this lecture, but at this point we start using the log of income using the same data set, and I'm going to produce the table in one go. So now, yeah, so now we got this table, and that what we could see in the lecture slide. So obviously now you're very familiar now with these. Let me just plot the graph. So just this piece here of code that should produce the graph that you see in my slide. So in this example, we looked at log models, and we used this data set again from the same package. We loaded the data set in our environment, and as usual, we produced the summary statistics, as you can see, and then I run the model where I have log of that was the demand for chicken, have the log of quantity demanded, regressed on the log of prices, and then again this is using this data set, so I'm going to highlight this, and I'm going to produce the table, and that's what you saw in the lecture. Then we move to discuss dummy variables, and we use for that a different data set, and here's the data set we used, and we run a regression of the price of the house and whether the house is near the university or not, and that variable here is utown, whether the house is, so it takes only two values, 0 or 1. So 1, that means it's close to the university in town. If not, if it is far away from the university, then it takes the value of 0. And I'm going to just run the regression and produce the table, and that's exactly what we see in the lecture. Then we move to talk about multicollinearity. And for that, for multicollinearity, we used a different data set about wage, and it's called wage micro. I called it wage micro data. And before we learned how to import data from Excel. If you don't know how to do that, just go back to one of the previous videos I recorded in this series. So what I'm going to do now is to import the data set, and then this line here, I'm just renaming the columns or the variables of this data set, and then just to show the head of the data set, so explore the first few lines. As you can see, we have data about education. South is dummy variable, so it takes one if that individual live in southern area, 0 otherwise. Again, female is another dummy variable, so equal 1 if the person is a female, equal 0 is a person if the person is a male. And then experience, again, is the number of years of experience. union here is yes. If yes, if the individual is a member in a union, that means that it take 1. If not, it takes 0, and then other wage, age, etc. So other variables. So in this data set here, okay, so we named this, and what I want to do is to produce the summary statistics and of this data set, and that's the table that you can see in my slides. And then we'll run a regression here, and I will include a number of variables that I think it explain wage. And the model we apply here is log len, so we have log of wage, log of the dependent variable, and on the other side we have a number of independent variables that we think they explain wage. So run this regression and produce the table. And looking at this regression here, we saw, okay, how that most of the estimated coefficient are not statistically significant as you would expect. You'd expect experience to affect wage. You expect education to affect wage, but we don't see this in this regression. At the same time, we see reasonably high R square, and we explain why. We think this is reasonably high because this is cross-section data. And if you don't understand this, or if you have any question about this, just go back and watch the lecture. So we thought, okay, so we need to properly play around with this data and see what is going on. So what I did here is I used the library D player, and then I used some just loaded that library, and I created a subset of my data. So this, I call it my data, and then this is exactly the same data set we have for micro data. But then the reason I did that because I wanted to deal with to use a subset, so I can produce the correlation matrix. So what I did here, I used the function select from this library, from this package, and I passed the data set I want to select some of its variables. So again, I explained in the lecture why I did that, because I want to fit the most important variables in the correlation matrix for the most important variables in within my slide. So you could actually do that for all variables if you want to. So I choose some of the variables, and that means I created a new object here called my data, and that takes education, or include education, experience, age, married, and female, and then I use the core, which is the correlation, which produces the correlation matrix. And once you do that, now I have a new object which is called data correlation, which if I type it again and execute this, will give us the correlation matrix between these variables. And what we notice here is the high correlation between experience and age, and that's something expected, and that's why we suspect multicollinearity in our example in the previous regression. So another way to check this is to run an auxiliary regression, in which I actually regress experience on age and see how they are related. And this is also you can see this in the lecture note, this table. Okay. So now we know that there is some sort of collinearity between correlation between age and experience, and then we run the regression after deleting or dropping one of these variables that we think it's problematic and causing the issue, and we produce the table, the regression table, and we see that nearly everything is significant as we'd expect. So I did the same with after dropping experience, just to play with this and see what would happen. Again, it gives us some similar results. So it's all significant. So apparently here is very clear now that the problem was multicollinearity in the first regression. And that was the code that I used to produce the second lecture. Thank you for following, and please let me know if you have any questions. See you next video.